Okay, so there's a correction for the parts of equilibrium of the rigid body. Okay, so from the previous video, I mentioned about this slide plank. Okay, so this is the center, we know that. So this is the distance between the center of the plank and the force. So I wrongly mentioned about the angle between R and F is actually located as here. So this is the wrong concept. So as the correction, okay, so let's say our plank is about at horizontal position. So this is our R and this is our F. So we can see that from this diagram, we can see that F and R is actually perpendicular to each other. So we can directly conclude that the angle between R and F is actually 90 degree, which is located at here. So this is our theta. If for the slide plank, okay, so let's say this is our slide plank. So this is our R and this is our F. Okay, so as I draw it in terms of simplified diagram, so this will be my R and this will be my F. So this one will be my angle. So this is how we determine the location for the angle. Okay, so as we mentioned just now, if okay, so okay, let's say if the plank is held vertically, so this is our force and this is our R. So this is the direction of R. So we can see that the direction of R and the direction of F is actually in the same direction. So same direction, we can see that the angle between R and F is actually 0 degree. So this will not give us the torque and hence there is no rotational motion for this plank. Okay, let me give another example. So let me erase this one. So this one as well. So let me give another example. So let's say I have a rotational disc. So of course this is the distance between the center and the edge of the rotational disc, and there's a force here. So we can see that the direction of the force and the direction of the force and the distance of R is actually perpendicular. So since the degree is 90 degree, so the torque we got, which is RF sine theta, is actually maximum. So this will give us the maximum rotational force, rotational motion. Okay, so let me erase this one. Okay, so this one as well. Okay, so what if the direction of my force is actually pointing towards here? So as you can see that the direction of the force and the direction of the distance, which is from the center to the edge of the rotational disc, is parallel and in the same direction. So we can know that the angle between R and F is actually 0 degree. Or okay, so this is 0 degree. So the resultant torque is actually RF sine theta. So this will give us 0 torque and 0 torque, and there will be no rotational motion for this rotational disc. And so we can conclude that if this is our R, and here if our F is actually at 0 degree, and our F is actually at 90 degree, so this is where the plane where we start to, okay, let me write it down, plane where angles varies. So this is where we start to, how should I say, start to calculate the angle. So this is my F and this is my angle located. So this is the location of the angle between F and R. So this is how we determine the angle for the angle between F and R, so that we can conclude what is the magnitude for the resultant torque, which is Fr sine theta. Okay, so that's it. I hope you can understand more further after watching this correction video. Okay, so I apologize for my mistakes. So if there is any question need to be asked, so please comment below. Okay, so I will answer your question as soon as possible. Okay, so I'll see you in the next video. So that's it. Okay, thank you.